Hello, algebra students. Welcome to lesson 4.3, solving systems by elimination. So the second method of solving systems of equations algebraically, which just means not using graphing, is elimination. And so today our EQ is how to use elimination to solve a system of linear equations. Now, elimination and substitution are very similar in that we solve for one variable first and then plug back in to get the second variable. However, elimination, the method is in the title. We are trying to eliminate one of the variables. And so to do that, we're going to choose to eliminate when we have equations in standard form. And usually we're going to look for equations in standard form that have big variable or big coefficients. So numbers in front of the variables that make it difficult to try and isolate and substitute. So we want to keep our equations in standard form. And just a reminder that standard form is that ax plus by equals c. And we want to make sure that our variables are all lined up. So in this case, we have our x's lined up with each other, our y's lined up with each other, and that constant c lined up with each other. And that's important. So we always have to have those in a row. Now, when we eliminate, we're looking to literally eliminate one of the variables. And we do that because the coefficient is the same and has an opposite sign. Okay, so if we're looking at this system of equations, we can see here that the y's have the same coefficient. They both have a 1 in front of them. And the top equation has a positive y and the bottom equation has a negative y. So those have the same coefficient and opposite signs. So when we use elimination, we're going to combine these equations by using addition. So add the equations together. So when I add these two equations together, I'm going to combine the like terms. And for me, because I've lined them up, that's really easy. So x plus 2x becomes 3x. Y minus y eliminates. And then 7 plus 2 equals 9. And then from there, I can solve my equation for x. And then plug this variable or this value for x back in to the one of the equations and get my y value. So 3 plus y equals 7. So when I subtract 3, I get y equals 4. So my solution is the ordered pair 3, 4. And of course, I can plug that back in to my equations to double check. So I know the first one's true. 3 plus 4 does equal 7. And then 2 times 3 minus 4 equals 2. So I know that that ordered pair works for both of those equations. Now, sometimes we have equations that don't have the same coefficient or opposite signs, but we can manipulate it just a little bit so that they do. So my system this time is x plus 3y equals 7 and 2x plus 2y equals 6. So what I'm noticing here is that they're both in standard form, all the variables are already lined up, but I don't have the same coefficient on either of my two variables. So what I want to do is multiply. And what I'm going to multiply by is something so that these equations, one of my variable eliminates. So what I'm noticing here is that my x and this 2x could be manipulated so that they eliminate very easily. And to do that, I'm going to multiply this entire equation by -2. When I do that, I get -2x minus 6y equals -14. And my second equation just stays the same. So I'm going to redraw my set bracket. And then from there, I can add. So sometimes we need to multiply to get the same coefficient. Okay, so then I'm going to add. So when I add these two equations together, my -2x and my +2x eliminate. -6y plus 2y is -4y. And then -14 plus 6 is 8. And then I solve by dividing by -4. And I get y equals -2. Sorry, I messed up. -14 plus 6 is -8. And then -8 divided by -4 is +2. So y equals 2. And then I'm going to take this value and plug it in for one of my equations and solve to figure out my x. So x plus 3 times 2 equals 7. That's 6. So I'm going to subtract 6 and get x equals 1. So my ordered pair is 1, 2. And again, I can double check. 1 plus 3 times 2 equals 7. 2 times 1 plus 2 times 2 equals 6. So I know that I'm correct because this ordered pair works for both of them. Now I'm going to go ahead and share my screen a different to a story problem. Now this story problem is going to work the same way with elimination, but this time we have to write the equations first and then determine how we're going to solve. So it says a florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? So because that's our question, we need to make sure we define our variables for the different types of bouquets. So I'm going to say that X is going to stand for regular bouquets, and Y is going to stand for the mini bouquets. Now, we have to write equations for these so that we have a system. So I'm going to look at this extra info off to the side. It says each regular bouquet has 5 roses and 11 peonies. And each mini bouquet has 3 roses and 5 peonies. And then these numbers in the story, 118 and 226, help us because we're going to add all of the roses together to get 118 and all of the peonies together to get 226. So I'm going to go ahead and go back to my math journal. And what I'm looking for is the number of roses in a regular bouquet and a mini bouquet that adds together to get 118. So I have 5 roses in a regular bouquet plus 3 roses in a mini bouquet, and that has to equal 118. And then I have 11 peonies in a regular bouquet plus 5 peonies in the mini bouquet, and that added together is going to equal 226. Now, I definitely do not want to graph this because these numbers are huge and ugly. I definitely don't really want to use substitution because if I tried to manipulate and divide, I'd be left with some fractions. So what I'm going to do is use elimination because that's the easiest. Now, none of my coefficients match or are the opposite sign. So what I need to do is multiply. And there's nothing that I can multiply one of the equations by to make a coefficient that's the same. So I actually have to multiply both equations. And in this case, I'm going to multiply this top equation by 5 because that's going to make my y have a coefficient of 15. And I'm going to multiply my bottom equation by -3 because that's going to make my y variable have a coefficient of -15. So when I do that, I end up with 25x plus 15y equals 590. And then -33x minus 15y equals -678. So then I add my equations together. And when I do that, I get -8x. My 15y and my -15y eliminate, and that equals -88. To solve, I divide by -8 on both sides, and I get that x equals 11. Now that is telling me the amount of regular bouquets. So the florist made 11 regular bouquets. And then I have to use that value of x, plug it into one of the two equations, and solve for how many mini bouquets. So I'm going to choose the first equation. 5 times 11 plus 3y equals 118. So 55 plus 3y equals 118 minus 55. And I get 3y equals 63. And then divide both sides by 3 to get y equals 21. So she made 11 regular bouquets and 21 mini bouquets. And that is my answer. And as always, I want to think about it as an ordered pair. So I'm going to write that as an ordered pair just for thinking about it as a system of equations.